Alright, so we're learning a new method of factoring today. It's called difference of two squares. That actually should sound familiar to you because I pointed out to you in the previous unit what they look like, right? So here's what a difference of two squares looks like. We're going to have two perfect squares. An example of a perfect square would be 9 or 36, or can anybody think of another one? 49 is one. 64. 69 is not, no. 81. So we have to have two perfect squares and they are being subtracted. The rule does not work for addition. It only works for subtraction. To factor a difference of two squares, we set up two sets of parentheses. One is addition, one is subtraction. And then we take the square root of each term. Okay? Now, one thing I want you to remember is that you should always check for a GCF first. I'm going to make a poster to post on the board while we're doing this unit. And it's going to list all of the different factoring methods that we will learn throughout the course of the unit. And we always want to check for them in specific orders. GCF is always the very first thing we want to check for, because if a GCF exists inside a problem, a lot of times special rules won't work unless we take the GCF out. Okay? So you always want to check for a GCF first. So let's look at example 1. X squared minus 36. Okay, so our instructions here are to factor. So every time my instructions are to factor, the first thing I always want to look for is a GCF. X squared minus 36. It doesn't look like there's anything in common. Can you guys think of anything in common between those two numbers? No. This is only x's and this is only numbers. There's nothing in common there. So there's no GCF. So then I'm thinking, okay, this looks like a difference of two squares. How do I know? Is x squared a perfect square? Can I take the square root of x squared? What times itself gives me x squared? X times x. Okay, so x squared is a perfect square. Is 36 a perfect square? Yes. What times itself gives me 36? 6 times 6. Okay, so we have two perfect squares. Are they being subtracted? Yeah, so this is a difference of two squares. So all we have to do, and showing your work, is literally just applying the rule. So we set up two sets of parentheses right now. Make them blank. The symbol in one is addition, and the symbol in the other is subtraction. And then to fill in the blanks, we just follow this step. What's the square root of x squared? X. So x goes here in the front in the first one, and x goes in the front in the second one. You have to put them in the same order that they show up in the problem.
Oh, I know. So, I get it now. For the other blank?
Yes. So for the other blank, what's the square root of 36? 6. So 6 and 6. And that's your answer.
Oh my gosh.
How would I check that this is factored correctly? Multiply. Which method would I use to multiply? FOIL or box. So let's check it. X plus 6 times x minus 6. So we're doing a check. X times x gives me x squared. X times negative 6 is minus 6x. 6 times x is plus 6x. And 6 times negative 6 gives me negative 36. When I combine like terms, negative 6x plus 6x, what happens? They cancel, so I'm left with x squared minus 36. Is that what we started with? Yep. Yes, so we got the correct answer. Make sense? Yeah. Not too bad? It's just the opposite of what we did in the previous unit. We're just doing everything we did last unit, but backwards. Okay, so example 2. 100 minus y squared. Okay, so let's look at this. First thing we should always check for is a GCF. Can you think of a GCF in here? No. This is 100 and this is only Y's. There's nothing in common. So there's no GCF. So I'm thinking it's a difference of two squares. Is 100 a perfect square?
Yes.
Yeah. Is Y squared a perfect square? Yes. So let's set up our parentheses. One is plus, one is minus. And remember, we must put our numbers in the order that they are in the problem. This is the most missed thing that I see on tests, is that you guys get so used to putting variables first that you put Y in the first one. Okay? It needs to be in the order that it's given because subtraction order matters. Okay, so what's the square root of 100? 10. So 10 goes in the first blank in each one. And what's the square root of Y squared? Y. So 10 plus Y times 10 minus Y. And that's your answer. Okay, ladies and gentlemen, 4x squared minus Y squared. Alright, so, very first thing is I will always want to check for GCF. Let's think about 4x squared, guys. I want to start being able to try and do this in our head. What are the factors of 4x squared? 2 and 2, so that's 2 times 2 times x times x. What about 9y squared? 3 times 3 times y times y. Is there a GCF in there? No, there's absolutely nothing in common, so no GCF. Is this a difference of two squares, though?
No. Well, I don't know.
It is. Set up your parentheses. Make one addition, one subtraction. And let's think about it. What is the square root of 4x squared? 2x. 2x times 2x gives me 4x squared. So 2x and 2x. What about 9y squared?
It's 9.
3y.
Oh yeah, I forgot you heard.
And that's your answer. So you just are taking the square root. 4. X squared plus 9.
Why? Oh, yeah.
X squared plus 9. Okay. First of all, guys, just look at this one. Is there a GCF in here? No. Is this a difference of two squares? How many vote yes, it's a difference of two squares? How many vote no, it's not?
It is.
Everett, why do you say no? Yes. What does difference mean, guys?
What does that mean?
Difference means subtraction. Is this subtraction to you? No.
It's the sum of two squares?
There is no rule for sum of two squares, so this is what we call not factorable, or we also say prime.
Okay.
Prime means you can't break it down, it's not factorable, so that's it, we're done.
So if it's adding, you can't do anything?
If it's adding, you can't do anything.
Whoa, I hope all our problems...
Example 5, we have 4x squared minus 4y squared. Okay, so I'm hearing a lot of you saying, okay, we're good this time, it's subtraction, you're right. But what's the first thing I should check for, Everett? A GCF. Does anybody see an obvious GCF in here?
Yeah, 2.
Caleb. 2 is 1. Does anybody see a bigger one?
4.
4. Both of these have 4s. So let's factor out a 4 first. So there is a GCF of 4. So remember how we do that. We factor out a 4. And then what would be left inside the parentheses? If I have a 4x squared and I take out a 4, what's that? X squared minus y squared. Okay, now look at what's left over. Do you guys think we're done? No. What do you notice about what's left on the inside? They're still squares. It's still a difference of two squares. So now we have a difference, and I abbreviate to diff of two squares. Okay? So we had a GCF of 4, and then we have a difference of two squares. So you bring the GCF down, 4. It does not go away ever. And then set up your rule for difference of two squares. 1 is plus, 1 is minus. What's the square root of x squared? X. So x goes in the first blank. And then what's the square root of y squared? Y. So y goes in the second blank. And that's your answer. So we had to do 2 different methods of factoring in order to factor all the way. Sometimes you will see problems where you have to do 3 different types of factoring.
Wow.
Okay? Yeah. We'll have lots. We're going to have 7 different factoring methods. We have just learned 2 of them. Okay? You need to always make sure you are factoring all the way.
Wait, why would we have 7?
Whoa.
There's just a lot of different ways. Number 6, 3x squared minus 27. Okay, guys, let's look at this. When we look at these things, what's one thing you notice about this problem? Is it a difference? Are we subtracting?
Yes.
Yeah, so we're good there. Are there 2 terms? Yeah, so we're good there because we only need 2. Are these perfect squares?
No.
No. So it doesn't look like a difference of 2 squares yet, but is there something else in there?
Yeah, there's an X.
There's an x to the second. Is there a GCF?
No. Yeah.
What?
3.
Is there a number that goes into both of these terms? 3. So our GCF is 3. So let's factor it out and see what happens. If I factor out a 3, what's left over? X squared minus, what's 27 divided by 3? 9. Now what do you see? What do you see, Thomas? He sees x squared. Is 9 a perfect square?
Yeah.
So now do we have a difference of 2 squares? We do. So this is now a diff of 2 squares. Okay, so bring the 3 down. Set up your difference of 2 squares. What goes in the first blank? X and x. And what goes in the second blank? 3.
Stop it.
And that's your answer.
Stop it.
And you also identified a GCF without writing out all the factors. Congratulations.
Are we done?
Example 7. Okay, when I'm looking at this problem, I notice it is a difference, and I see kind of squares in here, but these are not perfect squares because it's just a y, not a y squared. But do you see a GCF? Is there a term in common between all of those? Y. So our GCF is y. So factor out the y. And that leaves me with x squared minus 25. Now do I have a difference of 2 squares?
Yes.
Yes, I do. So will you factor using difference of 2 squares?
Yes.
So bring the y down. And that's x plus 20, or x plus 5 times x minus 5.
Oh, mac and cheese.
I exclaimed.
Dude, I was just thinking macaroni and cheese in my head right now.
Example 8. 2x to the third minus 200x.
What?
Last example. Okay, this is obviously not a difference of 2 squares right now, right? So there must be a GCF. Do you guys see a GCF?
Yes.
Yes. They have a 2 in common and anything else? An x. So this is a GCF of 2x. So factor out the 2x, and what am I left with here? If I divide by x, or 2x, what's left, Christy? X squared. Minus 100.
You totally just want to make a game person really like one.
Okay, so now this is a difference of 2 squares. So we have 2x times x plus 10 times x minus 10. And that's your answer. Okay, difference of two squares. Really quickly, a couple of you were looking at the homework and asking about fractions. Look at something that looks like this. 1 over 100. 100 is a perfect square, right?
Yep.
But this is a fraction. Is 1 a perfect square? Yeah, 1 times 1 gives me 1. So what would the square root of that be? 1 over 10.
That's pretty dang on easy.
Okay, so it's the same as 1 over 10 squared. So it stays a fraction.